Can everyone see my screen? AI trends in Aotearoa?
Yep, we can see it.
All right. Okay, cool. Thanks, Paul, for introducing me. Good afternoon, kia ora, namaste. My name is Ambica, as Paul said, and welcome to my AI talk. The only thing permanent is change. We all know, we all have witnessed that change around us since we were born. It's been told that AI will change the way also how we work now. So I believe the knowledge of AI will lead us to that, adapt to that change. And with this thought, I'm here to set the foundation of AI and brought you with some cool examples of AI in Aotearoa. Feel free to ask questions if you have any time. As Paul just mentioned, I'm the engineering manager for BNZ. A brief overview of my role, I'm mostly involved in setting up best engineering practices for my domain and within technology as well. But interestingly, I'm also pursuing my master's in AI from Victoria University. And as I said in the slide, yes, objects are closer than they appear now. As we've been seeing so much of disruptive innovations and hype in the last 6 months, I'm sure you all guessed it right. It's, with the introduction of ChatGPT and other language model offerings by other organizations, we've been bombarded with a lot of information. We were talking about machine learning and AI as a future of tomorrow, like yesterday, and it's on our doorstep now, which we can't escape. So from last almost a decade, I think, executives and CDOs are passionate about implementing AI to achieve business outcomes with data-driven decisions and increase business productivity. So in fact, some of the tech companies have also invested quite heavily in AI, and they have come up with such great platforms as I just mentioned: ChatGPT, Microsoft Copilot, Azure AWS has got a lot of AI toolkits, and so on. So the main challenge is not just about implementing AI now, but it's more than just that. It's about AI ethics, security, governance, and also, very important, how we use the right use cases, which are easy to implement and high in value. It all starts with business-led strategy, in my opinion. And that's with this thought, I bring this agenda for everyone. Today, I'm going to cover a few interesting real-world trends around the world and Aotearoa with a focus on specific industry examples. But before that, I'll just quickly like to thank TransPower, BNZ, and Victoria University for sharing some great use cases within New Zealand. Yes, I'm going to talk about the trends and use cases in New Zealand, but I'm also quite interested to share what AI is all about. So just the few next slides are basically the introduction of AI. So we are entering into the future, and it's important we carry our history along. So for that reason, I'm just going to do a bit of high-level overview of the timeline of AI. Can machine think? This was the first time someone ever talked about machines can think, and that was Alan Turing, father of computer science and the decoder of Enigma messages during World War II. He was the person who has proposed that imitation game called Turing test. I'm pretty sure a few of you already have heard of that Turing test, which is basically testing the machine's ability to exhibit intelligent behavior equivalent to human. Though it wasn't the first time someone worked on making machine things. So if I take an example, we are talking about driverless cars on the road is pretty much close to us, but to be honest, there have been so many experiments in the past. In 1925, a real example is a radio control company called Hardino publicly demonstrated a radio-controlled driverless car controlled by another car traveling the heavy traffic streets of New York. And there are other examples also. If you go deep into the history of AI, back as far as 1300, I won't go in that far, but just a quick overview of the timelines. As I mentioned, Alan Turing was the first man to say that machine can think, but actually it was John McCarthy who basically coined the term AI, or artificial intelligence, for a conference devoted for this topic. And that's how he started calling as father of AI. But before a lot of innovations happened, there was a good time, big time. It was around 2 decades, where there was an AI winter, where people started losing the faith that AI will ever do any miracles. And that gave the people sheer disappointment, but also the funding for those research projects were dried up. But then suddenly, this whole thing ramped up again, and was the rise of machine learning, which was also called as the second wave. And then a lot of innovations happened between 2000 and 2020s: big data, image recognition, speech recognition, and autonomous vehicles, personalized medicine, smart cities. They were all being evolved over time. But along with that, the ethical concern, as I mentioned before, was around AI, and its impacts on job and society were also being increasingly discussed and addressed. And the big purple bubble that you see is the point where last year OpenAI's ChatGPT-3 version was launched, that made some big disruptive innovations to AI world. I will talk about generative AI in a short while, explain more about that. So basically, what is AI, or artificial intelligence? As in a simple statement, is it to build system that exhibits intelligence like humans. It covers a lot of topics or categories, such as natural language processing. You must have heard a lot recently in large language models, knowledge representation, automation reasoning, machine learning, computer vision, and robotics. That is very popular in medical, in household, everywhere. So we talked about AI, but and I also mentioned that machine learning is one of the components, but it is a big share of AI, covers a big share. So machine learning is basically a subfield of AI, which is focused on building algorithms that can learn from data for themselves. So you have a training data, and the model basically learn from that and can result on some of the unforeseen data. And the deep learning is another very popular type of machine learning techniques that are getting popular, especially in solving complex problems or image recognition or generative AIs as well. Is a subset of field which basically uses artificial neural networks. And it was this artificial neural networks, as it sounds like, was inspired by how the human brain filters information. Any questions so far, Paul?
Nothing so far.
Nice. Okay.
Everyone's trying to ask questions, but we'll get there.
All right. So as I said, learning in machine learning refers to a process in which machine reviews the existing training data and learn new skills from that data. And machine learning can be categorized as supervised, unsupervised, and reinforcement learning. So since machine learning has a major share in artificial intelligence, I would like to go a bit brief in detail in machine learning. So I'll just quickly explain what supervised learning is, what unsupervised, and also touch on reinforcement learning a little bit. So basically, supervised learning is the analogy that normally we use for supervised learning is something like, we have a classroom full of people and we have a teacher who's basically teaching us some particular topic and basically connecting the dots and mapping us to the topics. Similarly, supervised learning in machine learning basically train on a labeled data. So the data with all the subfields as well as with the label is given. It's just that the machine learning models are trained on that. So basically, if these criteria matches, then this person has the disease, or if this criteria matches, then this person doesn't have disease. That's sort of benefit of having a class label in the data set. And supervised learning basically can solve two different sorts of problems, so classification and regression problem. That only difference between them is classification. Basically, all of our label data is categorical. So, when I just mentioned disease or not disease, negative, positive, or we have to have limited set of labels such as categories of wines or even flowers, or even we're talking about cybersecurity, different sorts of threats. Regression problem on the other side is basically deals with continuous value and predict continuous values and predict the makes the prediction based on that. So suppose we have to make predictions for a house price in an area in Wellington, or stock prices, temperature, weather predictions, that sort of thing. We use regression learning for that. Challenges with supervised is very slow as compared to other sort of machine learning algorithm, and it's very expensive because you have to label all of your data. So if you have 100 million records in there, you have to basically label all data. Algorithm which is trained on unlabeled data is called unsupervised. So we basically don't have any target field or label field. And this type of learning basically help turn data into groups or clusters, basically based on the statistical properties. And unsupervised learning are basically used for solving problems such as clustering and association. So clustering is basically categorizing based on your some examples like annual spending, categorizing based on your music interest, or for example, you watch a movie on Netflix and then they give you some recommendations. That is based on clustering techniques. And the other one is association, which is like you have gone shopping and you have bought this product. There's highly chances that you will go and buy another product. In online shopping, this sort of, they quite heavily use this sort of algorithms. Again, the challenge here is we don't know how many clusters we have to make out of that. And it's compared to supervised learning, it has less accurate results and basically no way to measure whether the results are accurate or not, because we don't have a comparison. And then the other one that I mentioned is reinforcement learning. It learns from mistakes. It trains models on rewarding desired behavior and punishing undesired behavior. It's like how it very much symbolizes how you play games. So if you have achieved a level, you get points. If you fall in water, you die, you lose your life. That sort of work they do in reinforcement learning. And the examples have game playing, robotics. In fact, nowadays they use for training helicopters and drones. So it sounds like they are very much used in solving complex problems. So the example here is that this robotic vacuum cleaner that we can train using reinforcement learning. And if it takes the right action, for example, the dust is on the box number 3. If they have taken an action to move to box number 3, they will be rewarded. If they have taken the option to move to box number 1, then they will be penalized for that. And that's how they get trained. And the last part in introduction to AI is big data, because so far I have been talking about data as the primary source of machine learning. Some of the interesting facts about big data is, so in today's world, every day on Facebook, there are 50 million photos are uploaded. Every day, there are more than 300 billion emails are sent, and 5 million tweets are made. And most interesting fact is that estimated that 90% of the world's data was generated in last 2 years. But that said, big data, the term is very subjective. So 20 years, whatever was the big data wouldn't necessarily be a big data for today. So it's a very subjective terms in terms of, the time era. And the 5 components or characteristics of big data that we always consider while doing machine learning is the volume, variety, value, veracity, and velocity. And variety is one of the biggest challenge so far. I have heard from a lot of people who have been working in machine learning models. So basically, it doesn't matter how much data you have. If you're not using it properly, it's not enough.
So Ambica, I don't know if you want to answer a question just regarding the robot. I've got a question for you that's come from one of our attendees.
Yeah.
Yeah. Okay, so Jean asks, how do you reward or penalize a robot?
So basically, this reinforcement learning has 5 different steps in this. So they basically apply some policies in the machine learning algorithms. So they have an environment, they have actions, they have rewards. When the algorithm runs, basically, it's a set of instructions or code. When the algorithm runs behind, they apply those policies. There are Monte Carlo policy and some other policies as well. And then they learn through it. And then basically they receive the reward or the value, whatever they have defined in the algorithm, and then keep increasing the value. And if they are taking the wrong actions, so they basically see in the environment, are they following the wrong action, then they are reducing their value, basically. It is very deep algorithms, so we have to have a more detailed analysis on that. Does that answer some of your question?
Yeah, all good, thanks.
Sweet. Okay, so in terms of generative AI, I thought we have been bombarded with a lot of information in our LinkedIn, in our various portals that we have. Actually, myself, I have enrolled in so many portals to learn more about AI, and they all are talking about ChatGPT and large language models. So I thought it's good, it's getting popular, but we should learn a little bit about the history behind that. So I would start with, what is generative AI? So basically, this is a type of technology in machine learning or in artificial intelligence that can produce various types of contents like text, images, videos, or even synthetic data. You're wondering why we use synthetic data. So there are a lot of researches happening around the world that can't have original data, and they need huge amount of synthetic data. So with the help of generative AI, we could generate synthetic data. It sounds like it is popular just recently due to new interfaces for creating high quality text, graphics, and videos in a few seconds, but it actually started in 1960s in chatbots, but also got so much popularity in 2014 with the recent advancements in generative adversarial networks, which is a type of machine learning algorithm that generate convincingly authentic videos or images. In fact, the advanced version of GANs, generative adversarial network, basically have differentiator and creator. So one part of GAN, which is the creator, creates the images, and the differentiator basically differentiate between the real versus fake images. And it has got the penalty term as well in it, which penalized if there is a difference between. So the model itself evolving in multiple iterations to make the images more and more look like real. And the large language models is even a more advanced form of generative AI, which may make generative AI more mainstream, which is basically perform a variety of natural language processing tasks. Remember, I just talked about natural language processing tasks that could generate and classify tasks and answer questions in a conversational manner and translating text from one language to another. Why they are so popular now, why we have a bit of hype here, is because the generative AI was there, as I mentioned, from many decades. The earlier versions of generative AI required submitting data via an API or otherwise complicated processes that only developers who are familiar with Python or other typical AI machine learning languages, they could use it. Now with generative AI developed better user experience, you can just type, I want to schedule a meeting, or I want to find out some of the roles that suits me best, that sort of information, and they'll give you details. And that made ChatGPT quite popular for that reason, and it's on fingertips of everyone. The interesting fact about ChatGPT was that within no time, I think 3 days of launching, there were 1 million subscribers, and by the time they completed 2 months, there were 100 million active subscribers in OpenAI's ChatGPT. There are some advantages as well of generative AI, like the one I have just shown in the slide here. It generates the content, which may not always be production ready, but it can drastically reduce the time spent on creation. So you can see the bar chart that is here. I have taken the image, which has done some good comparison. So if you want to start something from scratch, the time it takes for brainstorming to drafting to editing is way more than if you are starting something with generative AI and you modify. But as I mentioned earlier, everything comes with some challenges. So generative AI has its own challenges or risk, I can say. It can provide inaccurate and misleading information, and it can be more difficult to trust without knowing actually the source. So if you are reading a book or you're reading an article, you know about the source of that information mostly. But if you are just using contents from generative AI, you may not have the right source, and that could lead to my third point, which is can lead to new kinds of plagiarism and ignore the rights of content creators. And it could also impersonate people for more effective cyber attacks or even hacking and breaches in your banks. How we can protect ourselves is by putting some right guardrails, which is applicable to anywhere whenever we are using new technology or new method of working. We always have moral or ethical constraints around it to make it secure and safe for everyone to use. So peer reviews, proper tooling in place could be quite helpful. Right governance with due diligence. If we are using some codes or third-party application, good to have a due diligence. If we have not, we do not want a certain sort of large language models, make sure you do proper due diligence with the third-party applications. And then educate the right process to avoid any data breaches, to have your data go outside your organization. And as I said, the world is changing and we have to adapt with the change. So there are challenges and risks around us, but it's important to adapt to the change and bring these and other guardrails in place to protect attacks or breaches.
Ambica, I've got an interesting question here from Magrim.
Yep.
He asks, why do model generating images have a flaw of hands and not have the correct number of fingers or hands, or the hands are not correctly shaped?
Sorry, can you repeat the question?
Okay. So Agrim asks, why do model generating images have a flaw of the hands? So they might not have the correct number of fingers, or the hands are not correctly shaped.
I still didn't get the question. Maybe if you can pass me that question, I can investigate more and come back to you. Is that okay?
Yeah, that's cool.
Sorry about that.
No worries.
All right. Are there any other questions before I moved on to the next section?
No, that's it. Yeah.
All right. So the next session is I'm going to cover some of the AI trends. We'll start with worldwide, and then we'll dig some of the specific use cases in Aotearoa. So the three topics that I'm going to cover today in applications worldwide is healthcare, cybersecurity, and transport. So you can see in the bar chart the massive leap of investment into healthcare in artificial intelligence space from 2014 to 2021. And that has been made due to, the recent pandemic hit, and which has massively challenged healthcare more than any other sector. So healthcare can be used, the AI in healthcare can be used for early detection of diseases such as cardiovascular diseases, strokes, cancer, by analyzing the data. And the data is taken and captured from everywhere, from health records. Now we have wearable devices and even the medical devices. Drug discovery is another good example or use case for AI in healthcare that improve quality of care by speeding up drug discovery. And the third one is medical robots that has made a huge drastic innovations, especially in rural areas where it's hard for medical facilities to go or help surgeons with improving the success of surgery. Cybersecurity is another good example where recently in last year, in 2022, Checkpoint Research created the report saying that average weekly cyber attacks per organization increased by 38% compared to 21. You can see how much threat and breaches are happening. So it's more and more important to apply AI or smart, modeling into cyber security to detect threats and prevent any breaches. So it can be helpful in detecting new threats by classification tasks that can be performed on some installed software like intrusion detection systems to classify whether the request is legitimate or attack, or even can identify what sort of attacks they are. Similarly, there are other cases like bot attacks. You differentiate between whether it's a genuine bot crawling for the search engine crawlers, or it's a bad bots or even humans. It could classify between them. And then the third one is to understand the asset inventory, threat exposure, and predict which are most relevant, vulnerable, and allocate resources in that area to protect. And the third is transport, and that's my favorite topic. I'm learning more and more about that. Self-driving vehicles, especially the cars, are very popular nowadays. We're talking about self-driving cars, but industry also thinks that the self-driving trucks, they can reduce their operating cost by 45%. Another one is traffic signals. We all think that it's easy just to stop on a traffic signal when it turns red. But the reality is that every year there are 1,000 people in United States killed on traffic light. So basically, with AI, companies are incorporating computer vision-based system in vehicles to detect traffic lights considering factors such as weather conditions, other lights, to basically classify or predict, implement those special technologies in their vehicles to prevent those incidents to happen. And the last is traffic flow analysis. Traffic congestion, as we all know, cost us time, money, and also is a big contributor to global warming. So help traffic flow analysis can help identify the root cause for congestion by implementing some smart cameras that can detect vehicles, bicyclists, or even pedestrian. So this video that I have added here is from 𝗨𝗏𝗀𝗃, which is a Swedish company that has their software that detect traffic patterns by identifying or categorizing whether it's a car, which speed it's going, whether it's a pedestrian, and so on and so forth. Oops. Okay. Any questions, Paul, or anyone?
No, there was just a follow-up on the previous question, which is just about to overcome the model that's not depicting hands correctly. It was just to create it more different types of hands, shapes, sizes, finger patterns, etc. So yeah.
So are you talking about videos basically here?
That's the original question was around getting AI to depict hands and the fact that it's not getting it quite right. The shapes, the sizes, the number of fingers, and how do we overcome that?
Oh, so okay. Now I think I got your point here. So I won't give you an exact example of where this has been applied because I haven't actually myself have done this, but I know how we improve on the machine learning algorithm. So basically, first and foremost is that the data that we feed into machine learning algorithm needs to be processed in a way that it can be useful for machine learning to generate higher accuracy. So if it is not giving the accurate results or what we are expecting, we try to pre-process that data. I'll show you in one of the example later, but we try to pre-process the data to make it more useful for our machine learning models. On top of that, sometimes we compare with which machine learning models gives us the better results, or sometimes we use ensemble techniques where we are basically putting one machine learning technique on top of another, or maybe collaborate more number of machine learning algorithms that can help predict better accuracy results. Apart from that, image recognition or video processing has a lot of features in it that causes curse of dimensionality. It's basically a very popular term in big data, where we have n number of features. So for example, if we are talking about handwritten characters, we're capturing them as images. It has around 784 different features. And it's the more features you have, it's hard to predict because you need a big data. Like I'm talking about millions of rows in that data to accurately divide or categorize that data into different categories. So in that sense, we use some feature manipulation techniques like reduce the dimensionality but keeping the information intact, or creating new principal components. These are few of the techniques that we can apply on machine learning to improve our algorithms. Does that answer some of your question?
Yeah, I think it does. Yes, thank you.
Okay, cool. Thank you. Thanks for explaining. All right. If no more questions, I can move quickly to the use cases in it. Just quickly check my time. I have good 20 minutes. So in two use cases that I'm bringing, two different sectors use cases that I brought today that are from organizations in Aotearoa are financial services, which I'm going to cover around fraud detection and financial difficulty, which I've taken from my own organization, BNZ. And another one is power generation, predict and prevent failures, and cost optimization, which was an example from Transpower our state-owned power generation company. I'll start with BNZ. So if you don't know what BNZ is, so it's one of the four leading banks in New Zealand. It started in 1861 in Auckland and first branch in Dunedin. Since they are growing their business in all areas, they're just applying a lot of innovative techniques to help their customer, prosper and support their communities. I spoke to one of their advanced analytics teams, and they give me 2 use cases that they're actually implemented so far. And one is to predict financial distress. Financial distress is basically a condition where the customer couldn't pay, they become defaulters, or they have suffered from hardship or not able to pay their dues like for a big amount of time. And that could happen due to illness, injury, relationship broken, or unemployment. But a step before financial distress is financial difficulty. So our team basically has applied machine learning models on the financial difficulty symptoms or signs, and basically can predict who is on the trajectory of going into financial distress. They use machine learning models such as supervised learning techniques that it captures the data, the trends, apply some ethical data science, and identify their customers who are in financial difficulty. They label their data as either saying shows signs of distress or signs of difficulty, or moving into financial distress, that sort of label. The another one is prevent financial crime, which is another use case from BNZ. They do it by doing some customer due diligence. They used to have an old rule-based system that had some limitations that were they were not able to actually capture high-risk customers, and the results that were generated by that rule-based system was mostly false positive or false negatives. And someone like a financial analyst or other person who knows about financial crime sits and investigate again on that data manually to identify who are the actual high-risk customers based on the prehistoric data. So they have applied the machine learning models on that historical data by monitoring their transactions and identifying any suspicious activities. And those activities could be something like, someone has made huge unexpected payments, or they're doing regular payments. They're showing some abnormal pattern between themselves or some other third party, or any other sort of change of behavior. And that basically help them to predict the right high risk customer. Once they identify, they basically help stop the crime. Though they have the use cases, they're using machine learning models, they also have some challenges. One of them is to help set the target values. As I mentioned in predicting financial distress, we have to label our data. So they have to basically ask the business to help label data, which not always very easy. And as I mentioned before, one of the key components or key characteristics of big data is variety. And most of the data in organizations are unstructured, like images or data which is not in a standard CSV or database. So basically, team has to gather data from different sources, reformat for modeling. They are another challenge, like they have approved pattern to go into the target state, but they have some resource constraints. Though they feel like if they're able to meet these 2 criteria, they feel like they are successful in achieving machine learning modeling into their system. When the models and patterns are fully adopted and people have culture change, so when I said labeling the data, it's always helpful if we have right labels for the data, but also there are some challenges around explaining the value of machine learning versus, whether it's a reporting task or a machine learning model. So adapting to change and accepting that machine learning is a better approach. It's always a success criteria. And in future, they're planning to explore some probability learning techniques such as Monte Carlo simulation for demand forecasting, which helps them predict lending applications, what would be the workload when the OCR or interest rate will change. Any questions from BNZ perspective?
I would think that probably one of the challenges and the risks here on the BNZ model would be getting that prediction wrong, where particularly when someone's been identified as a possible financial distress, and the model gets it wrong, it could have a big reputational issue.
Yeah, so that's a very good question, Paul. That's where we always say that AI and machine learning are, helping us move faster, but that won't replace the value of humans in the system. So even though we identify our customer, we have validations process in place to basically identify whether this is a right, accurate predictions or not, and it's cross-validated with business. And in terms of identifying customers in distress will actually lead to more like, sorry. I don't know what happened. Oh, sorry.
No worries. Just whilst Ambica's getting her PowerPoint. Oh, there we go. I'll keep quiet now.
Sorry, missed. Did I answer your question or?
Yeah, that's fine. We've got 13 minutes left.
Yeah, I will wrap up quickly. I think a couple of more slides and I'll quickly pass that. TransPower, that's another interesting organization that's working heavily on machine learning models. It's a state-owned enterprise for electrical power transmission in New Zealand, and it mainly have two important functions. They own the national grid and provide the infrastructure for electric power transmission for consumers, and also system operators. So they have a task of managing real-time operation of grid and physical operation of electricity. So for them, 24/7 grid operation is paramount. I spoke to the practice manager in TransPower, and they gave me some use cases. So first is filtering general actionable alarms from noisy alarms. So they have assets called substations. So the data along with alarms information is sent to the operators. But in case of an incident, a lot of alarms information and data is being fed, and the operators get overwhelmed. So basically they apply machine learning models to differentiate which operator should get what sort of alarms, and basically provide the enable the relevant teams to take appropriate actions based on the predictions. The second use case is predictive root cause analysis, that although they know that they have differentiated and categorized their alarms, but they also want to know what the root cause or the failure, reason for failure. So they've applied predictive root cause analysis machine learning techniques to help reduce outages and identify cause of failures. Most of their root cause analysis is categorical, is like detailed text data. So they have to use some natural language processing algorithms to identify keywords that cause the incident. Challenges, Again, they have a variety of data which is structured. Some of the data is unstructured or form of images and text that requires needs to apply some machine learning, as I mentioned, natural language processing and computer vision to deliver project objectives. Noisy data, which can create bias and noise that can even produce wrong model results. I think explained with the help of pre-processing, it can reduce some of those impacts. And the pipeline. So they're building the models. They want to have develop machine learning pipelines, or they call it MLOps, as most of the modeling requires scheduling and automation. They're exploring and implementing MLOps to enable machine learning model cycle management from experimentation, development through to deployment. And the success for them is basically enable successful business outcomes through data-driven decisions and produce good quality and accurate results. Data is centralized, so they don't have to gather the data from all of the places. They're using Snowflake at the moment as a warehouse, and having standard machine learning pipelines and best practices in terms of some better DevOps tooling and automated deployments. Future for them, they're also working on so they have drones that captures the conditions of their towers and substations. So basically, at the moment, processing those images into making real data is all manual. So they are keen to automate using artificial intelligence so that they could easily predict the condition of the tower and make suggestions on when to paint and maintain those substations. AI opportunities in Aotearoa. I will quickly touch base on that, being mindful of time. AI in New Zealand has been evolved over time, and a lot of research is happening. New Zealand is quite popular in terms of the tooling that they are basically developing over the years. Two of the very popular tools that they have is R and 𝗨𝗏, that is being used worldwide for experimentation, research, and education in terms of AI across the globe. And you can see AI has opportunities in New Zealand in primary industry, climate change, and tourism, to name a few. A quick overview of the solar power project that I have helped my daughter for her science fair. So basically, we have gathered, I'll explain a little bit after that, but it's more around predicting the forecast of how much solar power will be generated with this amount of panels. The reason why we wanted to do this project was, everybody is going towards zero carbon in the next coming years. We want to identify or predict or basically forecast the demand versus supply. And also that can be help in maintenance of the solar farms as well. So this was a model that we have used. So she was taking the regular manual readings. So we have taken 6 manual readings every day. And then I clubbed them with the historical data from the weather API that I gathered. And if you can see in this diagram, that information that I just talked about, pre-processing the data to make it more useful to apply machine learning on it. So the data was in different categories, so we have to make it more numerical so that it can be used for predictions. And then taken another forecasted data from weather API to basically predict the future volts that can be generated in the next coming days. And then we compared with the actual. The results were quite similar. I wouldn't say accurate, but quite similar. Here's our information. We had 120 records because we captured 6 readings each day for 20 days. And we had 36 features with 1 target value. and out of which 8 were categorical. So we had to convert those categorical values into now numeric. So like sunny, cloudy, partially clouded into 0, 1, 3. We also have a feature of this daylight saving on and off. Forecast was to predict bolts, and the challenges which we think lead to not the exact accurate results were because we were only capturing a very limited data set. We just had 3 hours recording. We didn't have any IoT devices, and there were like 36 different features. So it has curse of dimensionality, and weather conditions differ. You know, Wellington is very unpredictable. The benefit we think the project we did was a mini version of this solar power plant, which is world's largest solar power plant, spread over 57,000 hectares in Jodhpur, Rajasthan. The total capacity of power generated is 2,245 megawatts, and it has around 10 million solar panels. Just imagine with this huge solar power data set can be useful for AI modeling and applications such as forecasting, as I mentioned, optimization of solar panel placement and orientation. So they should be on the north end, but depending on various data information, we could reorientate it with to get better results, predictive maintenance, storage and demand response, and for benchmarking. And that's my last slide. Paul, anybody has got any question? Otherwise, I can quickly wrap up.
So one of our, Abhishek said he worked at that project, the one that you showed with all the solar power. So he's worked there. That was
solar power.
Yeah.
Oh, that's great to hear that. That's amazing.
I've worked on solar forecasting as well. Just a side note.
Yeah. Oh, that's amazing.
Discussion for later. Yeah.
Yeah, definitely. So by now we have covered some good information about AI, and I think the real world use cases that I've given would be helpful for you to understand more about AI. But I didn't mean to scare anyone to say that the job after having AI or machine learning in place, the job of people are at risk. I don't believe so. As long as I've mentioned in the beginning, if we are open arms to adapt the change, we will have ample amount of opportunities to apply our skills that we currently possess in the field of artificial intelligence and machine learning. In fact, I was watching an interview other day where the interviewer mentioned clearly that by 2025, there will be 85 million jobs displaced, but then there will be 97 million jobs in various sectors like healthcare, education, renewable energy will be generated. So I think I will wrap up here by saying that what's the best way to start AI in your organization is to look around. It's a top-down approach. Start with having conversations with the management, include that in your organization strategy, and basically identify the best use cases that can have the highest business value, and just go from there. Thank you.
Thank you very much, Ambica. Thanks everyone for attending. I think we've got time. We've got 2 minutes left. We've got time for just one question. If anyone's got a question, please unmute yourself and feel free to ask. That was an awesome presentation, Ambica, and thanks for that insight. Yeah, no questions coming through. Okay, well, I think a question on mine, because we're talking to mostly business analysts here, and what sort of skill sets would you suggest for BA to work on as a starting point to get into the AI space?
Okay, I think as a BA, we all have a lot of analytical power, and in artificial intelligence, 70% of our time spent on analytics, understanding the data. So there are different areas like data analysis. Like you have huge amount of data. If we can help identify and process large amount of data, identify some of the patterns, uncover those, and help the business, that would be one of the skills that would be needed. Apart from that, we also use apply predictive analysis here. So you can, who else knows better than you, who are actually closely working with the product, to help with identifying the best business outcomes from the use cases. Another is identify what are the opportunities for automation. So AI is about machine learning to help predict, but also help to automate some of the tasks that are quite manual. So help identify some of the opportunities to automate. And the last thing is, as I mentioned before, it comes with a lot of challenges around ethics and moral science. So apply your analytical power and identify how we can guardrail our systems from going into any sort of breaches.